Hello, I'm back. Ready for our final segment today, which will be showing up right now. Retrosynthetic Analysis. What is that again? Do you remember? We have to start with the end of a synthesis and figure out how to make that from things we're allowed to use in the first statement. So we're allowed to use alcohols of 4 carbons or fewer and acetylene. And it looks like we made a molecule that's got an alkyne in it and a alcohol. Did we do any reactions today that ended up making an alkyne and an alcohol in the same molecule? Maybe we can use those as a guide. Let's go back this way. Page 2. And I have a molecule with an alkyne in it and an alcohol right here. It looks like 2 of the carbons came from acetylene and the rest of the carbons came from an epoxide. So take a look at these 2 pieces and see where they ended up here. The acetylene on the less substituted carbon and the alcohol on the next carbon over used to be this carbon here. So acetylene is going to bring 2 new carbons here and the alcohol ends up on the next carbon over. So I wonder if we can come up with our own acetylene and what the epoxide looked like here. I have a blank version there for you and we'll put our answer here. The new bond was from the acetylene. Let's close this. To the carbon that's 1 away from the alcohol. And you remember your retrosynthetic arrows. Let's use light pink. Look like this. It means I know how to make the molecule above the arrow from this down here below the arrow. And those 2 pieces are acetylide nucleophile plus an epoxide electrophile. Keep in mind, this got attacked. Next carbon over has a methyl on it. Same carbon also has an ethyl on it. And I may have to adjust my question a little bit to make it easier to do. I did a quick count of carbons, and that worked out to be 5. Get my eraser here. And go small. Sneak a 5 in there, see if I can get away with it here. Close enough. Yeah. 5 carbons or fewer. All right. Now, this is not acetylene, and this is not an alcohol with 5 carbons or fewer. Acetylide, though, is a molecule that comes from acetylene. So that is something on the list. That's acetylene. This guy here is an epoxide. Do you remember where epoxides came from? Always. In fact, they're always named after the thing they come from, which was an alkene. What 2 carbons used to be the alkene? Well, it's the 2 carbons that are the epoxide. We had an alkene from here to here. There you go. And this is not on the list of molecules I'm allowed to start with, but it's one away from those. Look at that. You have two choices here. You could have the alcohol here and do a dehydration to make this, or the alcohol here to do a dehydration and make this. If I was a pickier instructor, I'd prefer to use the alcohol here because the dehydration of a tertiary alcohol is a lot faster than that of a primary. But in lecture course, we're not worried about easy and hard. We're worried about things that can be made to work. So I would accept either this alcohol or this alcohol. You don't have to give me two, just give me one that works. Okay, so part A is answered here. I know how to make this target from these two things, and then you have two new retro problems. I know how to make this acetylide from acetylene. I know how to make this epoxide from this alkene. I know how to make alkenes from alcohols. This or this, they'll both work. And you take your, this is part B, the forward synthesis. We have a nice short segment here. You take your acetylene, react it with something like KH, and get acetylide. And need something for acetylide to react with. We'll start right over here with our more substituted alcohol. There's a good argument to say that that actually isn't a great choice. After I think about it a little bit, if you dehydrate this, you'll probably make more of the alkene here, which is more substituted, than the alkene here, which is less substituted. So that's that. I'm going to change my mind. I'm allowed. This could only give that alkene right there. You can't go in two directions from here. There's only one way to go. Once again, if you gave me this one, worst case scenario, I'd take a half point off because you don't get as good a yield. That's not the end of the world. And we react that with the chemicals that allow the dehydration of alcohols. I think this is the third time we've seen it today, maybe just the second. H2SO4 with heat. Little note. Little sad face. There. And now I need to make my epoxide so that I can react it with the acetylide. So this epoxide needs to be made from this alkene, and we can use our per acid. You can use per acetic again, it's just an easy one. Gives us this epoxide here. And then we would finish to get to our target by reacting first with acetylide that you made up above it. Second, you got to protonate to make your target. Target has an OH up there, you see it? OH right here. You need HCl to do so. And you've made your target molecule. Right there. And that brings to a close our lecture today. And I hope you found it useful. And hopefully we have all segments saved by Monday. And I think I have an idea how to make sure we don't screw this up. Well, I don't screw it up again. Look forward to seeing you Monday. Take care of yourselves and keep reading all of the material. Try those flashcards. Monday, we're going to get right into nuclear magnetic resonance, which was the other chapter I sent you. And if you have read it, that chapter is going to go a lot smoother, and things I'm going to say are going to make a lot more sense. So have the whole chapter read if you can. So your goal is to review your flashcards over the weekends, get your syllabus quiz done, your signed document, get your OWL due dates. I still haven't changed. That'll happen soon. And I'll see you next Monday. Stopping and ending.